Hello people, welcome back to my series on building a virtual machine in C++. Last time we built a Lexer and there's actually a few mistakes in that Lexer, but if you look in the link to the code in the description down below, you'll be able to find the correct code for it. And if you remember, we were working on SASM, or the stack assembler. And so we have this Lexer written. Now what we need to do is we need to write the stack assembler to use this Lexer. So let's go ahead and create a file called sasm.cpp, and we'll go ahead and start writing the actual assembler. And so what we'll do is we'll include a few files first. IOStream, we're going to include fstream, and include we're going to include our Lexer file that we had. We're also going to do a type def for uint 32 and make that I32 just to have a nice shortcut. And we're also going to use namespace, the standard namespace, just to make things a little bit easier to write. So the functions that we're going to have are, let's see, we're going to have a compile to instructions, which is going to take a vector of I32, and I'll take vector of strings, and I'll also we will need a function called isInteger, and a function called isPrimitive, and the isPrimitive function will actually tell us whether something is a primitive function or a defined function. And actually we probably won't need this to begin with, but we'll put this here anyway. And the other one, the very important one, is called map to number, and this function will take in a string and it will map that instruction to a number, which will be the binary output that we'll have. So let's go ahead and create the main function. And our main function will actually use the command line arguments. So we're going to check for input errors. We're going to check for input errors first, and we'll do that by checking if argc does not equal 2, and we'll print out an error message if it's not. And we'll exit. Then we can go ahead and read the input file, which will create an if stream. And we'll open up the file, file.open, and we'll open it with the first argument, first command line argument, and then we'll check if infile was able to open successfully. If it wasn't, we will print an error. And we'll exit. Now what we'll do is we'll create a variable called line, and we'll start to read the output of the file. So we'll get the contents, and then we'll read this file line by line. So we'll use getLine for that. We'll read into line, and then what we'll do is we'll do contents will be the line plus a new line. Then what we'll do is we'll close the file because we're done reading it. Now we get to parse the file. And for that, we'll use our new Lexer that we built. And we will gather up our lexemes by lexing the contents that we read from the file. Let me look at my notes here. Then after we've done that, we can compile those lexemes to binary. And we do that by creating a variable of vector I32, or 32-bit integers, and we'll call it instructions, and we'll compile to instructions our lexemes, and now we can write our binary instructions to a binary file. And for that, we'll create an OF stream of an out file. We'll open our out file. We'll call it out.bin, and we'll make sure that it's a binary file, and then what we'll do is we'll loop through each one of our instructions, and we will just write them out to the file. Let's see, after we're done with that, we can close our file, and we're done with our main function. We'll return 0. Oops, let's open that up, go down to the bottom. So now that we have our function created, all we have to do is write our other functions that we need, our supporting functions like compile to instructions, and that'll be about it, I think. So let's do that. Vector I32, compile to instructions, and we'll take strings. And what we'll do with that is create a vector called instructions, and we'll go create a little loop here. So for the size of our list of strings of our instructions, what we're going to do is we're going to loop through each one of our string instructions, and we'll check if it is an integer. And if it is, we'll push it onto the instruction list. And we'll turn our string into an integer. Oh, otherwise, what we'll do is we'll create an instruction, and we'll do a map to number. There we go. I think we got that right. Map to number, yep. And then what we'll need to do is we need to check if our instruction, if it doesn't equal -1, then we can push our instruction. Otherwise, we'll say that we have an invalid instruction. Oh, let's print that instruction out, just to let people know what's going on. Then, let's see, then what we can do is just return, return our instructions. There we go. Now, what we need to do is we need to write our other helper function, so let's create our isInteger. We'll take a string, and we'll loop through every digit or character in our string, and we'll check if it is not a digit. It's not a digit, we'll return false because it's not an integer. Otherwise, we'll return true. And that's it for, oh, whoops. Let's see here. Otherwise, we'll return true. And that's it for that function. Now we'll create a function. Let's see, actually, do we need isPrimitive? Let's create it anyway. Let's create isPrimitive. I don't think we'll need it right now, but in the future we'll need it. Well, let's see. Actually, let's just create map to number. That'll make things a little bit shorter. Okay. Map to number takes a a string and returns a 32-bit integer. So we'll check and see if, and basically what we're going to do is we're going to check for the command that we're looking for. So let's just do, let's create lots of them. So if our string is a plus, we'll return a hex number, and let's see, 1, 2, 3, 4, 5, 6, 7, 8. Good, that's 32 bits. And else if s equals minus, we'll get some of the basic operations here. We'll do return, make that 2. S equals multiply, make that 3. We'll have divide, and we'll make this 4, and I think that will be good for now. And let's also, at the end, if it's not found in any of this list, let's return -1, because this will be an invalid instruction. Alright, so now we actually have our SASM, a very primitive and assembler, but we have an assembler, and let's try it out. Let's create a let's actually create a file for our assembler. Let's create test.sasm, and what we'll do is we'll put a number on there. We'll put 3, put 4, we'll add, put 2, multiply. Let's see, that'll be 7, that'll be 14, and then 16. So let's add 2 to that, and then we will also divide by 4. There we go. So that's a nice little program where you've got some math. So let's see if we can compile our SASM. So we'll do. Oh, you know what? Let's create. Actually, we need to create a makefile for this. So, and our time is running long. So what we'll do is next time we'll actually make a makefile for this program. We'll compile it. We'll run it. We'll debug it if there are any bugs. And then after that, we'll work on taking our program that we compile into a binary file and run it on our virtual machine. So thanks for listening, guys. Till next time, have a great week.